Still just waiting for people to show up.
Yeah, that looks like a pretty good sized group. We'll probably get started.
Cool. So first thing on the agenda is Stackpacks.
Yep. Maybe we should do the, what's the second thing on there?
Layer origin metadata.
If we think that's like less than 20 minutes, maybe we should do that first.
Sounds good. Dan, did you also want to put offline build packages on for today too, or?
Yeah, we can talk about it. I feel like I don't. I had some exchange with Emily. I feel like this probably needs more thought before I present it again. But
Cool. We'll start with layer origin metadata, then do Stackpacks, and then if you want to bring up anything about the offline build packages, we can totally do it too if we have time at the end. Should we start? I guess. Is that Paul?
Yeah, hi. Yes. Okay, so I put this on the agenda after having a little back and forth with Jesse, who suggested that this was ready for like wider attention. So we'll see where that goes. Just to give like some overview of like what this is and like where it's come, and yeah, and what it's arrived at. I would say that the central like problem of the RFC is around something that we're calling traceability, which is like tracing like the inputs to like a layer, or at a higher level to an image. And that that traceability is related to reproducibility, but I think that reproducibility is not like actually concerned with identifying inputs. Reproducibility is just about like assuming we have all the inputs. If you take all these inputs and do the same thing with them, you will get the same result. But there still is this problem of like, okay, well, how do you identify these inputs? So that's what this RFC is about. If you want to know where the layers come from, like you have to know like what was used, like what the inputs were, and what versions of things you used to work on those inputs and all that. Hopefully that's clear, but I don't know if anyone has a question about that. Please feel free to let me know now. Go ahead.
Where reproducibility is sort of interesting to me with regard to the proposal is that if we put some of the metadata about build time dependencies in the image, it'd be hard to reproduce the image, right? And so I think the idea is like with the report toml, we can represent build time metadata without putting it in the image, so we don't affect the reproducibility of the image if irrelevant things, about the build process change. Is that still kind of the path we're on?
Yeah, it's still the RFC still has things has all this information going into report toml. The layer origin metadata will end up in report toml.
Awesome.
It's not it shouldn't affect reproducibility. Yeah.
Sounds good.
Or it shouldn't hurt it. Yeah. Okay. So yeah, on that note, I can also say there's like a mocked up version of what such a report toml would look like with layer origin metadata inside of the report toml. I forgot what else I was going to talk about here. Sorry. So, but I think that those are the high level kind of important aspects of this RFC. But recently some big kind of complications I think have come up. So for example, it's kind of easy to know what version of like an application source code you're working on or you're working off of. But those aren't the only factors, and it's easy. And if you have this layer origin metadata, it's easy to know like what the previous version of the layer was. But those aren't the only factors because as Jesse brought up, the platform can like mount things into the build environment. Can provide like volume mounts for it, and the big example of that I think of is like root platform env. That whole thing just kind of appears magically because the platform, puts it in there, and the things in that directory, becoming environment variables might have some effect on the build process, or on the build and the results of the build. But those, like I wasn't taking that into account at all. And, even trying now to take it into account, like acknowledging that platform env exists, I don't know how to deal with that. It's not clear how to deal with stuff like that, because, it's just any kind of volume. It doesn't have like an identity really.
For platform env is always just like a standard set of environment variables, and it might make sense to record that in the thing. But you mean just the platform dir you can mount arbitrary directories inside of?
Yeah, I mean, well, look, yeah. So platform env is kind of easy to represent because it's all just plain text stuff.
Right.
But I mean, I don't know that you're restricted, in such a way that you can only mount in plain text stuff. Like what if someone did like mounted an executable that way, and like it gets used. I don't know.
You can't mount into platform env though, just outside of
Right.
env in the platform dir. You mean? Yeah.
Yeah.
That makes sense.
Like for whatever other things like the platform might want to provide, like
Right.
by mounting a volume. Another example that was brought up was like TLS certificates. Like that could also be mounted in. And yeah, like if it's plain text, it's you can definitely represent it easily, because it's already text. But whether you want to or not is also a question. Like, is it really big? Is it going to be obnoxious and taking up a lot of space? And then there's still like another question of like, okay, well, what about things that aren't easy to represent as plain text? Like, I don't know.
Well,
Bindings
also,
are another good example, because one of the reasons you mount them in is because they're secret, so you don't want to be writing them to a file like this, right? I wonder if the goal here shouldn't be 100% perfect description of every input, but we just pick the ones that are most troublesome. Like, how far can we get just by looking at what the big pain points are in traceability and addressing those?
I might even, because it's not just service bindings, it's like people use caged secrets and mount them to random places in an image. If they're just using the image, like it doesn't matter if it was built with cloud native Buildpacks, like, I guess this is talking about build time though. Because lots of secrets come in via volume mounts, bindings are not, and because people sometimes put secrets in using environment variables, it seems reasonable to kind of cut that out of scope for now, and then figure out a way to like, do we need a whitelist or allow list or deny list different secrets that come in.
Yeah, that sounds practical.
Eventually.
Yeah, it's the secret. The example of like mounting in secrets is really useful, like as something that you would not want to represent literally, in this report toml. So I'll try to think more about that, and think about like sticking with the biggest pain points that exist instead of trying to account for all this.
We pick one or two of the more straightforward but valuable things, and we can get it in and implement it. Then we'll have a framework that'll be easier to add more things into, and we can,
Right.
if those things are complicated, we can take them on one at a time.
Right. That sounds good.
Cool. Yeah, I think if that's it, I think you probably want to push this out of draft state, and then folks can start commenting and get that and voting and whatever, in the next week or two.
Yeah, I'm cool with that. We can talk more about like the specifics of that outside of the working group meeting.
I'm looking through it. The only things that kind of struck me are some of the people might have a lot of feedback on some of the names of things, like application source versus source, making it consistent with a little more consistent with some of the metadata on the other side. But aside from, minor stylistic stuff, it looks really good. Excited to see it get in.
Thanks.
Anything else on layer origin metadata, or should we move on to Stackpacks? Yes, Joe, you wanna kick us off?
Sure. I put a few things on the list. I think we'll start though. Jesse and I were pairing on it this morning and came across some more like tactical questions. Actually, Jesse, do you mind talking through some of those, like running as root?
Sure.
And all that?
Yeah, I think that's the first one that probably makes sense to ask. We know that the builder has to run as root to do the actual build phase. It came up when we were implementing the detect part of this, whether detect should also run as root in this case, or whether we want to restrict that to not run as root. I don't know if anyone had any thoughts there on.
It makes sense to me that it should, because it might want to look in root-owned parts of the file system to see if it needs to make a change.
That was kind of our gut feeling there as well, is that you probably need to.
How does detect work stage-wise, though? Is Stackpack detection going to run with the other Buildpack detection before something, and so we need another phase?
No, the way we're doing it is by basically inserting the Stackpacks into every group as optional Buildpacks.
Interesting. Stackpacks run before everything,
They
and
run
so
after everything in detect, but in the build phase they run before, right, currently implementation-wise, but it doesn't matter in detect, I guess.
So the detect with the Stackpack doesn't run during the same detect phase as the rest of the build packs. Can you just outline the ordering of the operations for a build?
Yeah, so the way the detect works is every group, we basically append the Stackpacks to the end of every group.
Beginning of every group.
The end of every group currently.
Yeah, actually, the end, because that mechanism was already there. That's the mechanism that a meta build pack uses to expand itself. So we could easily switch that to where it's like prepended, but order kind of doesn't matter. So we just threw them at the end.
For the build plan interaction, all the providers have to come before all the requirers, and because Stackpacks are only providers, I feel pretty strongly.
Okay, I wasn't sure about that. I thought maybe it was resolved at the end and didn't look into it. In any case, that's a trivial change. They can go at the beginning.
Cool.
Yeah, and then they'll run in the build phase before all the other ones, right?
The detection for the Stackpacks runs during the build phase?
No. It still runs in the detect phase. I was just saying post-detect phase. In the build phase, all the Stackpacks run before the other build packs. Isn't that? Yeah.
So what I was asking about is if we have to run, do we have to run detection as root now in order to run the detect binary of the Stackpack as root? Because then it starts to get more complicated.
Yeah, unless you want a separate phase.
I think we would probably need a separate phase, but then you couldn't use the resolver and the detector as easily to, you'd have to run a special Stackpack detect phase out. It's not running in parallel, and then take that information. And
I mean, we can also do the same thing where if there's no Stackpacks, that same thing as builder, where if there's no Stackpacks, you just run detector as non-root and it's fine. And if you run it as non-root, maybe we just don't detect Stackpacks. So it's sort of like an opt-in thing. If you run it as root, it will run detect for Stackpacks. And of course, if it doesn't run detect for Stackpacks, they'll never run in the build phase.
I wonder if we're being overly cautious by saying that the detector, the lifecycle detector process itself, when it is running non-Stackpack, should not be running as root. I feel like the detector can run as root this whole thing, but when it executes bin detect, it does that as the correct user. It's probably the most straightforward way to do this. And unlike builder, which is more complicated because we're writing a bunch of files whose permissions we need to be constantly modifying if we do that. I feel like the detection has fewer of these edge cases.
Still makes me nervous.
But why concretely?
We've had to rebuild certain things internally because there are K8s platforms that have policies where you can't run anything as root.
But this doesn't stop you from running the detector not as root in a case where you're not using Stackpacks, right?
So
Like you have to be able to run something as root to get your Stackpacks anyways. It's like, do we bother to do a complicated re-execing of the detector and now I guess like a build plan merge for all the different groups? Seems a little bit hard to me versus just executing bin detect as a different user.
I was going to say, how certain are we that we need to run detection for Stackpacks as root? Or do we really have use cases for that?
No, I was going to back it up to that too. Yeah.
I think we should go one of these two paths and not. I think the other version of this is too complicated.
Between those two, I would go for detection must run as a normal user for Stackpacks.
I would go bin detect. Should be root.
I feel like we're going to instantly get asked to run as root if we decide not to run as root for detect. There's going to be someone who needs to read something they can't access to make a decision.
Like what?
I don't know. I need to give it some more thought. We just thought about this right before the meeting, basically.
My justification, probably very weak justification for saying that I don't think that would happen very commonly, is that if it's something that you can't access as a normal user and you're in a containerized environment with no kernel processes or anything like that, then that surface area is not going to be exposed to the application anyways because the application isn't allowed to run as root. And so I posit that it would be at least very difficult to think of an example, and we could relax the restriction later and add a more complicated system for running detection as root if we needed to because it's less restrictive.
It's like a root detector.
It gives us a path forward if we need to. If we start as a normal user, it gives us a path forward to move the opposite direction, and we can start with the simplest implementation.
And furthermore, if there were a stack pack that required special access or some kind of insight, that would be provided by the stack maintainer, who would have control over the stack in a way to potentially make sure that is exposed to the stack pack. So if there's some weird, I really don't even have an example, but if there was some weird thing, we could put it on the stack pack author to ensure that.
You can put a file in your stack image. It's just like, hey, stack pack,
Yeah.
do this.
I mean, sure, right? I mean, it's that the contract. That's the contract, and it's owned by the same person.
And user interface wise too, I feel like just the idea that, okay, you can run, yes, a stack pack can run something as root, but only in this one isolated place. This is your opportunity, right? That feels like it's doesn't leave a lot of room to mess things up for end users.
Okay, so somebody put yes in the notes.
I'm going to change it to no now. Yeah. I guess another one. Yeah, we talked about this. I figured maybe someone would know off the top of their head. So if we're injecting these stack build packs into the detect phase, do we know what the behavior of a group that has all optional build packs, is that even allowed? So if we inject an optional build pack in somewhere in the beginning of a group, is it going to cause problems doing it that way?
If only, I think the thing he's thinking of is if only the stack build pack passes and nothing else passes or something like that.
Oh, that's a good one. I'd say fail, or do what we say now, no build packs detected. At least one normal build pack has to pass. I don't know, maybe you just want to build with a stack pack. So we have a case right now, we'll give a very specific use case, where in Cloud Foundry we had a build pack called the binary build pack that was a no-op. The binary build pack was kind of a terrible name. It really did nothing. The only purpose was that Cloud Foundry couldn't build an app without a having something in the build pack field, having some empty bin build or bin compile script to execute, right? And in Cloud Unit build packs, we have for the Potato project at least, we have a build pack called the proc file build pack that we just put at the end by itself, so that you can use a binary build pack like use case with no build packs at all, right? Because generally we don't have a project toml yet, you have to set a start command somewhere, and so that kind of fills that niche pretty well. Once we have project toml, right, it's almost like you really may want an empty case there, right? And if you have a stack pack that's actually doing something that you want to happen, and you don't want to be forced to specify some other build pack, right? I think it's kind of a larger problem, that's my point.
Is it valid to have all optional in a group? Is that valid today? Does anyone know? Or do you have to have one that's required?
It's valid to have
It's
all
valid.
optional, but
They can't all opt out though.
Right. If they're in the end, if the detector has no selected build packs, it says none detected and fails out.
So so that's the problem, right? Because you could have,
problem.
if we're injecting some optional ones that will pass, suddenly the group that would not have passed would pass because the stack pack is in there. So I think that might be a problem.
Yeah, you always end up getting the first group, basically.
Yeah, the first all optional group, basically.
First all optional group.
Yeah, and I think this is where something like the Java build pack or set of build packs would always be a little bit eager. And, that's a very specific case where this happened, and it wouldn't resolve any of the other groups.
Ben's Java build packs are generally all optional, and so they could all fail off and then eat the group if all the optional ones failed, something like that.
So so maybe what we need to do is at the end of each group, check that it is not just Stackpacks that passed. That's not too bad. It's a little awkward, but
should we allow? What if somebody just wants Stackpacks to run, and like they want the Stackpacks to run, and then optionally they want to do something
that's
else?
like your proc file case. Is that what you're talking about?
Well, I think it's just a larger design decision. It's like, what if you have a use case? I want my app build pack to install this package, and then I want maybe this ISV integration to run, and then that's my app is already precompiled, and I'm setting my own start command via Project Toml, right? Seems like it'd be a super common use case for some end users, and what we're talking about here would actually fail that.
Right. Is it possible that you could explicitly define an empty list of build packs as your build pack?
I was thinking about that. Like an
because
order.
then, it's just an empty order, and then we're fine.
But what if you actually wanted an optional build pack in that list, but you still wanted it to pass if the optional build pack failed, right? Which is the same case, but now you need New Relic
that's
support.
fine.
Well, so then you don't have an empty list anymore, and we're back to like.
But then you have one optional. I think what we're saying though is if it's. Wait, I'm confused myself now.
So say very concretely, say you want to install ImageMagick, and then you have an optional build pack for New Relic, and that's it. 2 build packs, 1 stack pack, 1 regular build pack, right? So what you want is ImageMagick to be installed, and then if your app needs New Relic gets installed. If it doesn't, it's optional, so it doesn't run, and nothing happened, or you get ImageMagick installed, and then your app is just ImageMagick on top of the base image, right? Yeah. Do we want to support that use case? Because it seems like it's just a subset of the use cases of that empty list.
Yeah, I think we just need to handle those 2 cases very explicitly. Like if you have optionals, like because what if you had 2 groups, optional for New Relic and then an optional for Datadog or something, and you only want one to pass. You don't want the first one to pass. So I think we just explicitly handle where the group has build packs, but the only thing that passed is a stack pack, in which case you fail the group. But if the group did not have any build packs and a stack pack passed, that group succeeds.
Stack pack, yeah.
So if you wanted to, you couldn't express maybe New Relic, maybe not, and definitely the Stackpacks with just Stackpack and then optional New Relic. You would have to say Stackpack New Relic, Stackpack empty list. I think I like that. It makes sense to me. So I'd say
Yeah, I think so.
it's okay if we continue to have the behavior of if no build packs pass, fail, as long as we have a special new case that's if you specify explicitly empty list, then that's allowed to go through and means that the stack packs run.
Yeah.
It's gonna be weird if you combine that an empty list order with another order. Expands
I was
out.
thinking about how this
but-
works. Like, I got a meta build pack that has an order that has dated dog that's optional, New Relic that's optional, and an empty list group.
It wouldn't be
Behaves
optional.
differently than. Oh, I guess it wouldn't be optional in this case because you're doing the expansion. But the
feel like most
empty
people are just
list
gonna
like makes
throw-
it optional differently, you know? Like you put the empty list in there and you can just have the stack pack and you don't and you can't. But I think that makes sense.
I think it works.
Yeah, I think it does too. This is extremely edge case though, and also I think most people are more likely to put like Datadog, New Relic, Acme APM in the same group all as optional. Like that's kind of the way the Packito Java build packs do stuff, right? It's like a whole bunch of optional stuff sitting next to each other.
Yeah.
Cool. Is that an answer?
Sure.
Yeah, I think
well,
so.
I think Joe's got a good understanding.
Go with that.
Yeah.
Let's do the next one.
Yeah.
Feature flag.
Emily brought this one up earlier today. Feature flag for lifecycle. We talked about this. All the lifecycle, or a couple of the binaries will have new arguments to deal with the stack group, and the stack group path, as well as the sort of run as root behavior that is optionally available. So we're trying to figure out maybe how to get, the next iteration of this merged in, so we don't have to constantly merge from main with all the stuff that's going to be going on there. So we're trying to figure out what the path forward might be to get this merged in with a feature flag.
We could do a poor man's version of an experimental API. You have to set CMB platform API to wild, unsupported, something, and then
But that would
you could use this.
But you're talking about still having the same code base, or you're talking about like like we would have to put guards around the behavior for that
Yeah, I'm
experimental
talking about
version?
using the same code base, but if you try to use any of those flags, first of all, they don't show up in the usage, and if you try to use any of them, they fail unless you set some sort of, I know what I'm doing.
Some of it is triggered not by flags though, right? Like the Stackpacks in detect are just on the file system, and maybe that's equivalent. Like that's just another way of handling a flag.
Yeah, but it could be a combination of that lifecycle version in var or something, right? The CMB version along with the existence. Before we even check for the stack build packs, we can guard those with that as well,
Yeah.
probably. I think the main one is like we're gonna have to do all this around all the arguments of the binary so that they don't show up in help text, right? So that it's not exposed and people don't start using it without explicitly opting into it. But I just wanted to make sure that was a path that we thought it was worth taking.
Mostly just threw it out there as an idea because I'm worried about what it will take to merge this if we end up making big changes to the lifecycle.
That's our concern too. I think we're already behind a little bit.
But I feel like we gotta sort of play it cautiously. I wouldn't want to merge it in if then the Stackpack stuff is also going to go through a lot of churn because that would make other work built on top of it harder, right?
think we could. It feels a little wrong to merge the lifecycle code before there's consensus on the RFC, just governance-wise, maybe, sort of.
Yeah,
I don't
no,
know.
I think that's fine. I think we're
But-
really close though.
Yeah, I agree. I was just gonna say, this really shouldn't cause a lot of friction, or like this is such a large change. I think it's very valuable to get it merged in as soon as we can. So if we're not, like, I want to call out specifically that we should, communicate what we're doing and why, if that makes sense. But if we do that, because it shouldn't look like, RFC is close enough. Let's just, get it in there without the consensus mechanism, because I really want to be good about following a process. But we should do whatever we can not to make it too much of an ordeal.
I think we still got a few checklist items to do. Like, I think our goal, and Joe, correct me if I'm wrong, right now is to get to the point. The first merge of this big feature set would probably be running the stack build packs only in the build phase right now to give some value to. I think extend image would probably come later. Is that right, Joe?
Yeah, that's what we're thinking, to phase it in.
Looks like 2 minutes ago, Terrence proposed an RFC for experimental APIs. So maybe if we get that through, then this can come in using that mechanism explicitly once we get some RFCs approved. But before we have all of the details worked out.
All right.
Cool. Yeah, let's talk about the validation thing.
Yeah. I think this one is about when in the process do we need to validate that a stack pack isn't including a normal build pack in case of like a meta build pack. And I guess the other question is, should we be doing that? And what does that mean?
Do we need meta stack packs? Could that come later?
Yeah, no, there's no reason a meta stack pack can't exist. Like, just in working through the code, it seemed really apparent to me that it would just work. But we've already talked about not having them be homogeneous. So it's kind of weird though. You're like, do I validate that at detect? Which is actually kind of hard, because the way meta build packs get flattened out, there's not really a good point to check that. Except for just like straight up like looping over them and like validating there, but also it seems like a weird place to do it. So, I mean, we could do it. Well, no, there's not really a stack package creation step. I don't know. It was just
maybe we can just forbid it for now.
Just wave a finger.
Oh, I mean, in the code, say like it can't be both a stack pack and a meta build pack. We can always loosen it up later.
Oh yeah, so you're saying the explicit, just like run through them, but at what phase? In detect, you think?
Yeah, when you go to detect it, when you see that it is a stack pack, if it is a meta stack pack, you just fail.
Oh, all right. Seems pretty cool that it just works though.
We said
fine, Emily.
The thing is, it doesn't just work, because who knows what's in there, and you got to loop over it and all that stuff, right?
Yeah, that's actually probably easy enough, because you make that check to look up the build pack at the same point too. And you have to change. You have to switch the directory you're looking in there.
I think this will relate to the next one, but if the way you add stack packs to a stack image is via the builder interface, then you can validate at builder time that it's what it is. And then if it's wrong at launch, if someone constructs a builder wrong, you can fix it. You can figure out something later. But it seems like at that point, it's maybe not worth a ton of extra validation.
That makes sense. Before we go on to the run builder, let me share this doc. I can't see my tabs. So I started putting together proposals for the mix-ins. Let's share this in chat somewhere. So yeah, I think this is another thing that, like Run Builder, I think we could actually punt on. But I think this we need in order to get, or for that first phase of getting a PR merged. But this, I think, based on the discussion yesterday, we need to sort out. So I think I have 4 proposals in here. One was a Boolean. You just, every provider requires the name could be a mixin name if mixin is true. Another is a top level stack provides, stack requires with a list of mixins that matches other lists of mixins. Stephen likes number 3, which is, oh yeah, so each provides could have multiple mixins. Is that, I think that's what this one is. I thought that was a little odd, but if I don't really care. And then the 4th one, wait, what's the difference between these?
You have a stack. You have a
Oh,
little
stack key.
stack key under
There's
there.
just an extra level. Okay, cool. Yeah.
I might have meant to say 4 for the one that I put my comment on, but I actually have a slight.
Yeah, I don't.
Yeah, sorry. Go ahead.
Go ahead. Go ahead.
So I have a grand unified proposal type thing here with the build plan and how this works. So one thing that's come up internally is we have use cases where sometimes a build pack needs to provide a dependency, and sometimes the dependency could be provided by the stack. And the build pack doesn't really care who provides it as long as it's there. So one big example is .NET Core needs ICU, which is super easy to install without a package and can be just downloaded by a build pack dynamically if you need it, if your stack's missing it.
Yeah.
We have a build pack that installs ICU. Don't want to slow down the build process just to install an ICU package. It's really, really optimally a build pack, but we also have stacks that include the OS package for it, and it's better if you use the OS package if it's there, right? So my crazy idea is you could make it so that the mixin, we wouldn't want to call it just mixins or stack mixins because that would have a very specific meaning. But if you put a mixins list at the top level of a dependency name, then if the mixins are satisfied by the stack, then the entry is owned by the stack, the whole entry. And if it's not, if the mixins aren't satisfied by the stack, then another build pack must claim the entry by name.
By the name, not the mixin
Name. Exactly. And for detect to pass. And then there are questions like if there are a whole bunch of weird cases with this, I think, and the meaning isn't terribly clear, but it's like if, a build pack would provide the dependency, but the stack is providing it instead, does that provider build pack fail the build? Probably not. It's like the same case as if another build pack provided the same dependency name, it could get pushed to it, but it wouldn't. And then there's a question of like, do we need a push mechanism so the build plan can push entries forward, or Stackpack can push entries forward if it can't act during build, if it can't actually. But then Stackpacks really start looking like build packs for how the build plan works, right? They have the same mechanisms. There's just the special mixins thing that lets a build pack claim an entry by a series of mixins associated with or lets a stack pack claim an entry by a series of mixins associated with the entry instead of by the name of the entry.
I think this is too complicated.
Well,
like, why can't the build pack that requires this say, I require mixin ICU or dot requires name ICU? Done.
Because you have to provide an entirely alternate build plan in that case. You're forced to use that OR mechanism.
Yeah, but we put the OR mechanism in there for that reason, right?
Oh, I guess. We put the OR mechanism in there, but we intentionally, it was more like when you have totally separate configurations of like you have a...
Yeah, but I'd rather have one complicated OR mechanism than two complicated OR mechanisms that works secretly through mixins/name.
Is that any...
So you're advocating for this one, basically, Emily, right? And you would just OR the non and...
Sorry, I was looking at the document, not at which one you're pointing. Which one's this one?
The first one. And you'd have like two requires, or I mean, rather... two requires OR together. One that's a mixin and one that's not. Is that what you were saying?
Yeah.
Means you need a build plan entry for every package you require, but that's not that weird, or like
I think that makes
could be more
sense
clean.
on some level. No.
The advantage of doing the weird overloading thing, right, where you provide mixins or a name, right, is that the build pack that needs ICU doesn't care about where ICU is coming from. But maybe it should. Maybe it should care if it's coming from ABI compatible ICU on the stack or not.
I could see, I think there's a lot of cases like that, like JQ or something that's like not commonly on a stack, but that like a build pack would need, and you might even need like a specific version of it. Like we see that with, I think with FFmpeg, where the one that's in, the package repository is not the right version that people need. And so as long as you can install it without root, you might want to opt for the more modern version or something like that.
Emily's, or like proposal 1 versus proposal 3, right? In proposal 1, you're specifying mixin or not mixin very explicitly with that or keyword, right? Where you have to provide an entirely alternate version of the build plan that has the mixin version instead of the other version, right? And it's more verbose because you have to duplicate the whole build plan thing you want to care about multiple times in order to do it, right? But if you look at the other example where you name the entry and you put mixins in it, you're still being less explicit about it, but you're still providing two options, right? You're saying the build pack requiring it has to say either name this or these mixins by putting those mixins inside of it. So it's not an automatic interface. It's not like you can just say ICU and then ICU can either come from the Stackpack or not, right? So maybe
What if you said name equals ICU, mixin equals true, and that's it? And then sometimes it can be provided by a non-Stackpack, but who says a non-Stackpack can't provide something that is true, is a mixin?
So mixin equals true, but mixin equals true doesn't mean it has to be a mixin. It just means it's allowed to be a mixin.
It means it's a defined mixin on the stack, which is usually probably going to be provided by a Stackpack. But if a regular build pack can meet the requirements of the mixin, it can also provide a mixin.
So you're saying a normal build pack should be allowed to say provides name equals something, mixin equals true?
Yeah, if we defined a mixin that's called JQ, and what it means is JQ's on the path. If a regular build pack can meet that, hasn't it satisfied the mixin?
I don't think that's what the JQ mixin means, though. I think it means this is an ABI compatible, version of JQ that can be rebased out from under the application.
Mm-hmm.
Yeah, that's the question.
But
if that's what it means, then yeah,
I think it means it's an ABI compatible version of JQ, and if a regular build pack can install an API compatible version of JQ, all the power to it. The fact that it's installed by a regular build pack means it never will be rebased. But it's not, that difference isn't in the delta itself, right?
That's not the use case, though, right? ABI compatible version of JQ is kind of nonsensical because it's not a library; it's a binary. But you know what I mean. But the point is that a build pack could satisfy it with a behaviorally forwards compatible, or however you want to describe it, dependency version, or it could be provided. It could be provided by the stack in a behaviorally forwards compatible way that allows for rebasing, with rebasing being the reason it would provide that. And then the mixin describes the behaviorally forwards compatible, version of it, and the build pack installed one does not. But you could do like mixin -OK equals true as the field, and then the name could be satisfied by the mixin version in the stack, and then provides could never, on a normal build pack, wouldn't ever say mixin equals true. I worry about naming conflicts a little bit if we do that, because now you're merging the mixin namespace and the contractual build plan namespace together.
I'm not super wedded to the idea I threw out. I think of all of them, I like the or between the two of them best, but I don't want a complicated these mix-ins equal this name situation, I think.
I agree that it's complicated. The only thing I like about it is that it avoids munging the namespaces together and still allows for the end behavior we want. But I agree that I don't like the interface for the reasons that you state.
And you like it better than the or? That the or is pretty straightforward.
But the or, and then the namespaces are totally separate and they can't be satisfied crossways.
Yeah.
I see.
If you want the namespaces separate, keeps them separate, and it uses stuff we already have.
And only Stackpacks can provide build plan dependencies with mix-in equals true in that case.
Yeah.
It's just that the or is so hard to use. That's the only thing stopping me from that.
Is
But
it
that
really
might be the
harder
best
to use
solution.
than what you're proposing? I'm not convinced, but
It just feels very weird that you have to repeat the entire build plan because one thing might be a mix and it might not, you know?
I don't know. I feel like we use in the Java build packs, we use the or with some regularity, and it's not so hard to use. We don't have very long build plans. It's usually like 2 different ways it could proceed, right? Doesn't feel complicated to use to me on the ground.
Because your build packs are super modular, but there may be build packs that aren't as modular. It's pretty theoretical. I'm pretty happy with that solution if we get to that, I think, probably. Joe, is this argument helpful?
I think so. So you've landed on proposal 1. Is that what we're?
Maybe what we're talking about is a version of proposal 1, but where regular build packs can't provide name equals dependency name and set mix equals true.
What's the behavior then? It just the detect phase fails if it tries to do that or something, or an error.
Is Forrest here? Or he had this, and I think he put something in the GitHub issue. He had a very specific use case around ICU in this. I don't know. Ryan, do you have any context on that, maybe?
No, I don't know anything about ICU.
Okay. I thought .NET Core uses ICU, and it can be either come from a build pack or a stack image. I think I get what he meant by it. I just wanted to double check. So I think this works for that use case as long as in the .NET Core build pack that he's working on, he could say this or is willing to do the build plan version and say or and then the mix-in version and repeat the whole build plan in that case.
Okay. Yeah, I think I can actually. So should I put this? I'm trying to figure out if this belongs in the Stackpack RFC or in the application mix-in RFC, where I would actually expand the scope of the application mix-in RFC to include build pack mix-ins.
I think sorry, go ahead.
No, just go ahead. I was going to say I'll write it up there.
I think my preference is, to me, this is like the underlying mechanism that, like,
triggers or is like part of the Stackpack interface. Is that what you're going to say?
Exactly right. It's like you could imagine that the mechanism for an app developer to provide packages, it could come from Project Toml, but that might just be a special case of using the build plan to transmit package information.
Yeah, and it's really a
just
platform feature. Yeah.
I just imagine it being a way for a platform to shoehorn in extra required into the build plan, basically.
Yeah. Which I mean, that was a question from Jason too. Was like, if I don't support Project Toml, how do I use this?
Exactly. I think explaining this is the underlying primitive that it's all built on top of, right? Using the build plan to transmit a special kind of build plan requirement that's for mix-ins to the Stackpack feels very clean.
Okay, so I'll add this to the Stackpack RFC, and I think I understand force use case enough that I might try to sketch that out as an example, even if it's very hand wavy around. I don't even know what ICU is, so but I think I get it in general.
Like internationalization stuff. But yeah, that sounds great.
I didn't say I wanted to know. I said I don't know.
Sorry. Cool. So is that all the mixin related stuff?
Yeah, there's mixed in, yeah. Then the only other thing was run builder, but if we think we can phase this in without an extend phase, I think we can punt on that a little bit, but tell me why I'm wrong.
This is kind of feels like a core question to me, and I left a bunch of comments on both the Stackpack and a few on the mixin RFC. But one of the main things that I was wondering about is there's a little bit contradictory in there about whether the Stackpacks are provided by the stack author or whether they're provided by the builder author, right? At one point, there's like maybe I just didn't understand, but there was like builder toml is how you add Stackpacks, and another part is no, Stackpacks come baked onto the images, right? And these suggest really different things for what a run builder, if that needs to exist, looks like.
I think
there's
the
something in
toml. Sorry, I don't mean to answer this for you, but this was a
we got
point
rid of that,
contention that I had before.
Yeah, and I thought we resolved it by getting rid of the builder toml stuff. So it is provided by the stack author.
The current proposal mentions the builder toml, but it's only so you can change the order of the Stackpacks, which I think makes perfect sense. Like Stackpacks have to come on the images, but if you want to create a builder that never ran the Stackpacks or something, you can do it in your builder toml.
So that in that case, we don't need a run builder. Is that right? There's just no reason to have that concept if stack images must be used to do with Stackpacks. I like that.
If we assume that Rebase has access to the builder, which, I'm not sure.
No, Rebase would just need access to the next run image, right? Because the next run image, so like the way in my head this works is the run image always has the build pack on it, but then when you export the app, it doesn't include the run image layers. But on Rebase, you're getting the next run image, and so you're always, should just always work. So done.
Yeah. All right, I'll read back through when I do this mix and change and see if I can clean that up in the Stackpack RFC too, because I don't think that's captured well at all.
Does that answer all your questions about Run Builder though?
I got a last question here for the requires provides and phase specific mixins. I guess what would happen if you only needed it for one phase is in your name for your mixin, you'd say run : mixin name. Are we assuming that we have the exact same set of Stackpacks on both build and run images and that they have the same capabilities when it comes to providing? So one provides will describe what's possible on both images. That's my question. I guess if it's not, you could still put the prefix in the mixin name to scope it. I don't know.
Prefix in the mixin name? Maybe?
Like you could say provides run :
Yeah, that's what, yeah. I mean, I'm saying I think I like that option. It almost like kind of brings back the how you used to put launch true and build true. We were like, should we put that at the top level? And we decided not to do that. But now it's like those could have real meaning here, right? Launch true means run : like, do we need to apply run : and build : to the build plan entry names more generally too? And is that the way that we get away with putting that metadata? Is there a more unified system for doing that, right? If we're going to have run : and build : for mixin equals true build plan entries, should we have run : and build : for not mixin equals true build plan entries in order to represent where you need that mixin or where you need that dependency? Because right now we'd be creating different interfaces for solving a similar problem.
I feel like if I was redoing it from scratch, I'd pull it out of the string of the name, but I think right now in the world we live in, that's the best thing to do.
Makes sense. We could pull it out of the string of the name in the build plan case completely, right? And just make it run colon and build colon are just ways you express that in the mix-in lists that are specified on the images.
Since we've already described mix-ins with those names, it'd be weird to not support people using it, and then doing both seems worse than just doing that one.
Run colon mixin is no longer a different mixin than just mixin. Like before, there were different mixins and the label just specified where they live. But with the relaxed mixins RFC that'll maybe get approved this week, like it's really irrelevant. It just straight up is the same thing, but just the run portion of it, right? So we have more flexibility to redefine what that looks like, without weird API related constraints. I had one very last thing. I know we're 2 minutes over, but one of the comments I put in there in the Stackpack RFC, I think, was about in Buildpack TOML, the mix-in list that can be provided. I think we need to move all that into the stacks list and make it per stack, and that will change the format of Buildpack TOML a lot. We don't have to go into a lot of detail now. I just wanted to call out that I think there's some work in Buildpack TOML we need to do on the Stackpack side. Anything else, or should we call it?
Alrighty.
Thanks, everybody.
Bye, everybody.